Welcome to KK Mishra's tutorials. Today we shall discuss all about projectiles. Now what is a projectile? When a particle is thrown at an angle near the Earth's surface, it moves along a curved path. Such a particle is called a projectile, and its motion is called a projectile motion. Let us be familiar with certain terms used in describing projectile motion. The point A from which the projectile is released is called point of projection. U is the velocity with which projectile is released. It is called initial velocity, and its inclination to the ground is called angle of projection, which is theta here. The projectile goes through its highest point C and falls to the ground at B after traversing the path ACB. AB is called the horizontal range and CD is called the maximum height. Time taken by the projectile in reaching point B from A is called time of flight. The magnitude and direction of velocity of the projectile changes continuously during the projectile motion. You can see here. But its study becomes easy if we deal with its motion separately in two mutually perpendicular directions, vertical and horizontal. We shall take vertically upward direction positive as y-axis and towards right in the horizontal direction positive as x-axis. Point of projection A will be taken as origin. Let us consider the horizontal movement of projectile. There is no acceleration in horizontal direction, so Ax is 0. The velocity in horizontal direction Ux is equal to u cos theta, and it remains constant during the whole flight. Initial velocity in the vertical direction is Uy equal to u sin theta, and the acceleration due to gravity is g, but we shall take it here minus g because its direction is downwards. So Ay is equal to minus g. Due to this acceleration due to gravity, the vertical component of velocity Uy equal to u sin theta changes continuously. This vertical component of velocity Uy equal to u sin theta is responsible for continuous change in the velocity during the projectile motion along ACB. There are three main items that we need to know in a projectile motion. Number 1, horizontal range AB. Number 2, maximum height h. And number 3, the time of flight t. It is preferable to calculate the time of flight t first, which is same for both vertical and horizontal movement. It can be easily calculated by the vertical motion under acceleration. Vertical motion. To calculate the time of flight in vertical motion, we use the formula s equal to ut plus half at square. Here, initial velocity ux equal to u sin theta, a equal to minus g because its direction is downward, so we have taken it negative, and s equal to 0 since the projectile comes back to initial level, so vertical displacement is 0. We get 0 equal to u sin theta into t minus half gt square. Taking t common, we get t into u sin theta minus half gt equal to 0. It gives either t equal to 0 or t equal to 2u sin theta by g. T is 0 for point of projection A and t equal to 2u sin theta by g for point B on the completion of the flight. So time of flight t equal to 2u sin theta by g. Now maximum height h. To calculate maximum height h, we will use the formula v square equal to u square plus 2as, At maximum height, the vertical component of velocity will be 0. So final velocity v equal to uy equal to 0. Initial velocity u is u sin theta. Acceleration a is minus g, and displacement s equal to h. Putting this, we have 0 equal to u sin theta whole square minus 2gh. That gives h equal to u square sin square theta by 2g. So maximum height equal to h equal to u square sin square theta by 2g. Now third is horizontal motion. No acceleration in horizontal motion, so it is a uniform linear motion with a uniform velocity ux equal to u cos theta. We have already calculated the time of flight, so the horizontal range r can be easily calculated as distance equal to velocity into time. R equal to u cos theta into 2u sin theta by g. That gives r equal to 2 sin theta into cos theta into u square by g, and we get r equal to u square sin 2 theta by g. So we have three expressions. We have calculated time of flight t equal to 2u sin theta by g, maximum height h equal to u square sin square theta by 2g, and horizontal range r equal to u square sin 2 theta by g. Problems related to projectile motion in S.C. Verma's Concepts of Physics Part 1 Chapter 3 have been solved in my blogs at kktutor.blogspot.com. Now, trajectory of a projectile. We may be interested in the geometric shape of the trajectory of the projectile. Let us find it. Let in time t equal to 0 to time t, the projectile moves from point of projection A to any point P having coordinates xy with initial velocity u and angular projection theta. See the figure above. Distance x equal to u cos theta into t. It gives t equal to x by u cos theta, and distance y equal to x tan theta, and distance y equal to u sin theta into t minus half gt square by putting the value of t from here. So we get y equal to x tan theta minus gx square by 2u square cos square theta, y equal to minus g by 2u square cos square theta, x square plus tan theta into x. And this is an equation of parabola in standard form, which is y equal to ax square plus bx plus c. In the derived equation, we have c equal to 0 because it passes through the origin, and a, which is coefficient of x square, is negative. That means the parabola is convex when viewed from upward direction. Hope now you can easily solve the problems on projectile motion. Thank you.